Welcome to Study Loop.
19.75. So we're told that a 1.35 volt mercury cell has an internal resistance of 30 milliohms, whereas a 1.5 volt dry cell has a internal resistance of 350 milliohms. So we want to explain why 3 of these mercury cells is better if we want to power something like a hearing aid with power consumption of 2.5 watts that needs 4 volts than 3 dry cells can, because 3 dry cells are obviously going to provide a higher voltage than the mercury cells. So something about the internal resistance must be important that makes having a factor of 10 lower internal resistance an advantage when it has a slightly less voltage. So let's figure out how much current this hearing aid wants. Excuse me. So that's just going to be the power divided by the voltage. So we find that it wants 625 milliamps. And so now we can figure out what the voltage, the terminal voltage of each type of battery is. So we have 3 of them in series. So we'll have the EMF for the mercury battery of our cell of 1.35 volts minus the current times the internal resistance. And this gives us 3.99 volts, which is pretty good. It's very close to the 4 we were asking for. Now for the dry cell, we do the same thing, except we put in the EMF and internal resistance for the dry cells. And the current is the same. That this would have to provide. And we see that because of the higher internal resistance, you end up actually getting a lower terminal voltage out of these batteries, even though, sitting by themselves, they produce a higher voltage when no current is being drawn. But once you start drawing current like this, the lower internal resistance of the mercury cell becomes much more of an advantage, even though its EMF is technically lower.